Please briefly summarize your industry education and professional background.
I'm an associate professor of civil, environmental, and sustainable engineering at Arizona State University in our School of Sustainable Engineering in the Built Environment. I hold a PhD as well as two master's degrees and a undergraduate in civil and environmental engineering. I've worked at a couple of universities in terms of graduate education, research sabbaticals, as well as kind of research scientist visiting professor type positions.
What is the Medici Center for Infrastructure and Sustainable Engineering at Arizona State University, and what do you do there?
So the Medici Center is a consortium of interdisciplinary faculty members who study infrastructure. Many are engineers, some are not. And the core goal of the Medici Center is to prepare infrastructure. Often we're thinking specifically about civil infrastructure systems like power, water, transportation, for the challenges of the future, and think long-term future that's marked by lots of what we would call destabilizing conditions. So, conditions and disruptions like climate change, maybe financial uncertainty, political uncertainty, kind of social technological change. All of these things seem to be coming to a head, and infrastructure need to adapt, or we need to adapt infrastructure to be able to provide the services that we might need in a wildly different future, a future marked by some of this uncertainty. So the Medici Center is designed to help us as infrastructure professionals find trajectories to essentially position infrastructure for success in the future.
Can you tell me a little bit about what you do there specifically?
I'm the director of the center, so I lead the center, and I am one of the main researchers of the center. So, I run a research program that focuses often on climate adaptation issues around infrastructure, but also, we do work around lots of other kind of destabilizing conditions, everything from cybersecurity to emerging and disruptive technologies, innovative ways in which we make decisions around infrastructure, whether that be around financing, the integration of green infrastructure, right? So we're studying lots of what I would describe as novel pathways for how we might do infrastructure in the future. So I'm a key researcher in that effort, but I work with lots of the other researchers in the center towards those goals.
So you also co-lead the Urban Resilience to Extremes Research Network. What are the main goals of this network? How does it work? And how did you get involved?
So the Urban Resilience to Extremes Research Network is a National Science Foundation funded interdisciplinary network of researchers across primarily the United States, although we do involve some folks even more broadly than that into South America. And the research network focuses on a handful of cities, 9 cities in the Americas, mostly in the US. So we've got Phoenix and Portland and New York and San Juan and Miami and Syracuse and Baltimore. All of these cities are essentially test beds for the network. So the network involves both researchers, academic researchers across 19 institutions, as well as practitioners on the ground in those cities. So the researchers and the practitioners are working hand in hand. And in doing so, we are actually trying to do what's called knowledge co-production towards climate adaptation, find innovative ways in which we adapt infrastructure for the particular needs and particular circumstances of what's going on in those cities. So the research network is, in its 7th year at this point. And in each of those 9 cities, we've essentially, as academic researchers, worked with practitioners to create new visions of climate adaptation. So for example, if you take a city like Miami that experiences urban flooding, you take a city like Phoenix that experiences urban flooding as well. And you might say, okay, how would the solutions differ? Where would there be overlap? Where would there be similarities? In which places do we harden infrastructure gray infrastructure? In which places do we utilize green infrastructure, for example? Do we always do fail-safe infrastructure, or do we sometimes do safe-to-fail infrastructure and sort of plan for the consequences and mitigating those consequences through kind of social and governance capacities on the ground there? So it's a large research network that's been quite productive at thinking in new ways about how we might adapt cities into the future.
So one more background question. What is the Engineering Research Visioning Alliance, ERVA, and why was it formed?
ERVA is a alliance that I spoke to recently. I'll be sort of clear here that I am not a spokesperson for ERVA. I've been involved in the processes that they've been using. Specifically, it's a National Science Foundation funded initiative that's been helping to sort of bring together different engineering research visions, different engineering research backgrounds, basically, to think about and identify the sort of research priorities of where engineering needs to go to support some of the major challenges into the future.
So in December 2021, ERVA held a visioning session about the role of engineering in addressing climate change. How and why was this session organized? What were some of its conclusions?
How it was organized, again, like I was a speaker in this, so I can kind of talk to, kind of my role there. I can kind of give you my perspective on it. I was not involved in the specifics of the organizing of it. But from my understanding, roughly 100 or so experts were brought together, and various speakers were given sort of a platform to talk about sort of future challenges. Like a survey was involved with roughly 500 members of the engineering research community, and this input provided some specific directions of where the engineering community should focus their efforts. Ultimately, where we might focus certain resources towards going forward. Resilience was a major theme that emerged, is my understanding from this topic. So a number of us spoke to that resilience theme, and then a lot of kind of the specifics of resilience kind of came out. What we were talking about, resilience is a big umbrella. So some of the ideas around what resilience might mean in terms of human and natural design, bioengineering based solutions, things like circular economy, circularity, closed loop systems, life cycle assessment. I think these were some of the big ones that emerged.
So based on what you've learned from all of these organizations and your own research, what advice could you give our engineering audience in terms of how they can plan and design for climate change? Can you give them one or two key points to keep in mind?
Again, my perspective, and this is not necessarily the URBA perspective, the key challenges for me when I think about climate change and what to recommend going forward is this idea of a decoupling between what is happening with our climate and what our infrastructure are capable of doing. So I refer to this decoupling often as the gap between what we need our systems to do, our basic and critical systems, things like power, water, transportation, and what they are capable of doing. So climate is changing very, very quickly, and there is a lot of uncertainty about how climate might change into the future. Infrastructure are also, of course, changing, but they tend to be changing on a much slower timescale. And I would argue that they're not changing fast enough, and we're not giving ourselves the flexibility to allow them to change in response to this uncertainty. Given that, I think that we as an engineering community need to view infrastructure in the face of climate change in a slightly different way. So instead of taking a focus on what we often do, which is hardening, strengthening, armoring of our infrastructure, building it tougher, building it stronger, hold back climate, that sort of thing, hold back the flood, hold back the heat sort of mentality. We probably need to give ourselves space to think about how we build systems that can be quickly changed. So instead of instantiating large, rigid assets for long, long time horizons, we instead, build systems where we can go in and change them when we've learned a little bit more about how climate change is actually playing out. We probably need to recognize that given the vastness of our infrastructure systems, there's so much of it that, and given the financing picture, it's tough enough to find financing for rehabilitation as infrastructure are today, let alone rehabilitating all of the infrastructure that's out there. So putting those things together, we will experience failures. Infrastructure will fail, whether it's the United States or on a broader scale as a result of direct perturbations from climate change. If we accept that that failure is going to happen, then we can start to think critically about how we manage failure. I'm not saying that failure is okay. I'm saying it's going to happen. As such, we need to think about how we design, how we plan for failures as they unfold, how we, of course, prevent loss of life, prevent major economic damages from happening. So we call this safe to fail. It's essentially designing for failure in mind. And it's sort of different than a model where we, often basically say, look, when failure happens, it's no longer the engineer's problem, it becomes an emergency manager's problem, or disaster manager's problem, right? Engineers need to, I think, or I would argue, start to bring this idea of planning for failure into the design process, such that we are designing systems that minimize these consequences. There's lots of good examples of this type approach. One would be, and I would encourage the listeners to look this up, Room for the River in the Netherlands. So certainly hardening, strengthening, armoring of our infrastructure has a place at some scale of the problem. But at a broader scale, I think there's a more fundamental challenge that we face of uncertainty and of our inability to quickly adapt all of the infrastructure that we have that necessitates new approaches that revolve around what we call agility, flexibility, maybe decentralization of infrastructure, safe to fail. There's a number of competencies that we look at in terms of, how we might position our infrastructure and the institutions that manage them to do things differently than how we've been doing them so far.